Suppose I surveyed 60 students and I asked them their gender, that's qualitative, and I asked them their hair color, that's qualitative as well. I can count all these frequencies, I can count all the combinations of these events occurring. So what's the probability they're male and have black hair? What's the probability they're female or they have red hair? And I can summarize those values, those frequencies, in a table. First, I would list one of the qualitative variables as the rows, and then the other qualitative variable as the columns. So the different categories for the qualitative variable gender are my rows, male or female, and then the different categories for the qualitative variable hair color are my columns, black, brown, red, blondish, blonde. And then however many times those combinations occurred in the data set, those are the numbers in the cells. So for example, there were 7 students who were female and had black hair. 7 students who are female and have black hair. That's how to read these results. And that's a contingency table. Okay, it's called an R by C contingency table, where R is going to be replaced with the number of rows that's in the table, and C will be replaced with the number of columns in the table. So looking at this one, we have two rows, male, female, by 1, 2, 3, 4, 5 columns. So this is an example of a 2 by 5 contingency table. Number of rows by number of columns. And then the purpose of this again is, I think it's simpler to solve those probabilities. We don't even need to use all those formulas I just reviewed. Some of them are just really easily identified from this organization of data. Okay, so if we look at the hair color and the gender, some preliminary work to solving these probabilities might be finding the totals. The totals are going to be needed for our denominators in the probability formulas. So it's just some simple addition. You add up the rows, you add up the columns, and you get those marginal counts. They're called marginal counts, or just the totals. So I added up 4 plus 7, that equals 11. 12 plus 15, that equals 27. Get all these columns totals. Then go across the rows, 4 plus 12 plus 1 plus 2 plus 5. That gives me 24. Get the row totals. And then at the very end, this 60 comes from totaling those totals. So 24 plus 36, that equals 60. Or 11 plus 27 plus 4 plus 7 plus 11, that also equals 60. So this bottom number down here, this 60, that's bolded, that's always your sample size. So that'll be lowercase letter n. We know now that there were 60 students sampled. It's just a good way to check and make sure if you're creating the contingency table, you counted all of the observations. And of course, if it was a population data set, if this was every single student in the class, then it would be big N. Capital letter N would be 60. Right? The difference is big N is the population size, little n is the sample size. So it just depends on if this is every student in my class or just a survey of students, on whether or not I'd label that big N or little n.